In this lesson, we'll be talking about verifying trig identities. Before we get into trig, I want to just give a brief perspective from algebra. In algebra, almost everything you wrote involved an equal sign. For example, if you wrote 2x plus 1 equals 9, there's the equal sign, and this is an equation because of the equal sign, but the equation is only true for one value of x, and you can probably easily see that it's only true if x is equal to 4, because if you take 2 times 4 plus 1, that would be 8 plus 1, which is 9. So it's true for 4. Now, only true for 4 is found by solving the equation, and that's the way I came up with the 4 to start with. So that's one type of equation you encountered in algebra. However, here's another equation that you saw in algebra. 2x plus 3x equals 5x. Now that's an equation because there's that equal sign. But this is different somehow. This is not just true for one value of x. This is true for all values of x. And you can see why it's true because if you just collect like terms, that's not really a math expression, but what you're really doing is you're using the distributive rule and factoring out the x, and you have 2 plus 3 quantity times x, which is 5x. And that's the way you would prove that that's true, using the distributive rule. Now, the point is, though, this is true for all values of x. Now, an equation that's true for all values of x is called an identity. An equation that's true only for some values of x is called a conditional equation. Its condition, whether it's true or not, depends on the value of x. Conditional equation. Now, in algebra, usually when you were trying to find out, when you were working with a conditional equation, you were usually trying to find out what value of x or what values of x would make it true. Solving the equation is the terminology that was used. When you were working with identities in algebra, there was a lot of different things that were said. Factor, where you would write a factored form of the same expression, which was true for all x. Or you may have seen simplify. Simplify covers a lot of things in algebra. Or you may have seen collect like terms. There are all sorts of instructions were basically having you work with identities. Add these fractions. That was another way you were working with an identity. So I'm just trying to give you that perspective. You've already seen identities, you've worked with identities in algebra, but you really didn't call them that. Well, in trig they do call them that. And so we've already seen a few basic identities called the basic 8 perhaps. They fall into 3 categories. There are the reciprocal identities. And these identities, all of these identities that I'm writing now, are things that come from the definition of the trig functions, and hopefully you've seen how they are derived. The reciprocal identities are that the cosecant of x is 1 over the sine of x. That's one of them. Another one is that the secant of x is 1 over the cosine of x. And another one is that the cotangent of x is equal to 1 over the tangent of x. And these are called the reciprocal identities because they're saying that one of the trig functions is the reciprocal of another one. So those are the three. In fact, you use those three early in the trig course when you had to find the cotangent of an angle using your calculator. There's not a cotangent button, and so you did it by saying 1 divided by the tangent of the angle. So now the next group of identities, only two in this group, are called the quotient identities. Quotient identities. And like I said, there's two of them. The tangent of x is the sine of x divided by the cosine of x. And the cotangent of x is equal to the cosine of x divided by the sine of x. Now you can see these identities are not really independent of one another. For example, if you know that the tangent is the sine of x divided by the cosine of x, and you know the cotangent is the reciprocal of that, well, you just flip the sine of x over cosine over, and you get cosine over sine. So these, like I said, these are identities that are called the basic identities, and that's the reciprocal and the quotient identities. And then they have another group of three identities called the Pythagorean identities. Pythagorean identities, and there's three of those. The first one, and probably the most often used, is the sine squared of x plus the cosine squared of x is equal to 1. Now that's a surprising looking result, because the left-hand side has got x's in it, and it would seem like if you change the value of x, you would change the value of the left-hand side of the equation. However, what this identity is saying is, no, actually you don't. You always get 1. So if you haven't tried that out on your calculator, put some values of x in and see that the left-hand side is always 1. And hopefully you know how to get this identity by going to the Pythagorean theorem and the definition of the trig functions. So these identities were not handed down on stone. They were actually derived from the definitions of the trig functions. Now, there's two other Pythagorean identities, lesser known perhaps, but one of them is that the tangent squared plus 1 is equal to the secant squared. Now, if you don't want to waste too many brain cells, you could derive this one by dividing the first one through by cosine squared. And then you have sine squared over cosine squared in the first term, but sine over cosine is just tangent. That's where the tangent squared comes from. And if you divide the second term by cosine squared above, you get cosine squared over cosine squared, which is 1. And on the right-hand side, 1 over cosine squared is secant squared. So you can if you knew one of these, you could figure out the others. And the last one is the cotangent squared plus 1 is equal to the cosecant squared. And I guess you can remember the last two. The co-functions go together in those. So cotangent, cosecant, and then tangent and secant. Now, those are the 8 identities that you saw derived from the definition of the trig functions. And those are going to be our tools. So we're going to use these 8 identities together with all the algebra, like the distributive rule, adding fractions, combining like terms, those types of algebra skills that you've learned, together with these identities to prove other identities. Okay? So that's what the topic is about. Now, let's start with this identity as our first example. The sine of x times the cotangent of x plus the cosecant of x has equal to the cosine of x plus 1. So this will be example 1. And the instructions are to verify the identity. That's the terminology that's used. Verify the identity. Now verify, you could also say prove. In other words, we're assuming at the beginning that we don't know whether this is true or not. So I'll put a question mark over the equal sign. The author is telling you that you should show that it's true. So you can't treat it like it is true. So you have to put that question mark over the equals in the sense in your mind so that when you get through, you'll know that in fact you have shown that it's true. So we don't know now that it is, but okay, suppose we think it is because the author said to verify it, and that would be rather mean of him to tell you to verify something that wasn't true. So let's see if we can see why. Now, what we need to do is we need to work with one side of this equation and try to rewrite it and do algebra simplifications and end up with getting the other side. Now, one of the strategies that's used in verifying trig identities is that often you try to work with the side that is, quote, more complicated, or maybe the side that has more things you can see to do. Now, when you look at this, the right side seems to be quite a bit simpler than the left side. And so we'll work with the left side and see if we can simplify it till we get to the right hand side. So when you're seeing how can I simplify this, well, one thing that probably jumps out at you is this quantity in parentheses here, the cotangent plus the cosecant. There's a big parentheses around that, and then a sign is being multiplied by that quantity, and so it's a situation where you can use the distributive rule. So if you think about the distributive rule, it says if you have A times B plus C, that's the same as multiplying A times B and then adding A times C. So we're going to do exactly that with trig. So we'll have the sine of x multiplied by the cotangent of x plus the sine of x multiplied by the cosecant times the cosecant of x. Now, okay, so that's a first step you could take, and better, to be honest, but at least we've removed one of the parentheses, and now we have two terms. And on the right-hand side, we have two terms. Well, that's helpful, or hopeful, I guess I should say. So, but if you notice, now you keep your eye on the right-hand side. You always want to look at where you're trying to go. And you notice the right-hand side has a cosine of x and a 1. The left-hand side, on the other hand, has a cotangent and a cosecant. Neither of those show up on the right-hand side. And so we need to get rid of the cotangent and cosecant, and a standard technique you use in proving identities is that you often want to change the cotangent, the cosecant, into sines and cosines. So if I do that here, I'll have sine of x, and then the cotangent can be written by our basic 8. That would be the cosine of x over the sine of x. And then the second one, the sine of x, multiplied by the cosecant, but we said by the reciprocal identities that's the same as 1 over the sine of x. So now I have replaced the cotangent by the cosine over the sine and replaced the cosecant by 1 over the sine. And the reason I did that was to hopefully have something I could simplify. Now, you can see in the first term that sine of x can be thought of as a fraction, sine of x over 1, and we're multiplying that by another fraction, cosine of x over sine of x, And when you multiply that, you'll have a common factor of sine of x in the top and bottom, which will cancel out, and you'll end up with just cosine of x over 1. And that's just cosine of x. And then, so this is just some algebra of fractions. And then in the next one, it's the same idea. The sine can be thought of as the sine of x over 1. And then when you multiply it by 1 over the sine of x, you have sine of x over sine of x, which is just 1. So cosine of x plus 1 is what we've arrived at, and that is the right-hand side. So at this point, this equals to the right-hand side, cosine of x plus 1, and we have verified the identity. Okay. So that's the end of example 1. Now the main things to take away from this is that you work with one side of the identity and you try to use identities and algebra to rewrite it so that you can get to the other side. The reason you shouldn't do something to both sides, like try to subtract cosine from both sides, is because you don't really know they're true yet. You don't know that the two sides are equal. And so we're going to work with one side and try to rewrite it and use algebra to arrive at the other side. So that's example 1. Now, example 2 will be the cosine squared of x minus the sine squared of x, all divided by the sine of x times the cosine of x. So that's one big fraction on the right-hand side of the identity. And on the other side, we have cotangent of x minus the tangent of x. Okay? Now, we need to try to verify this identity. So again, you look at it and you try to decide which side looks more promising to work on. And in fact, in this case, we're going to actually do this twice. The first time I'll do it, I'll start working on this on the left-hand side. And so I'll work on the left-hand side. And then after we finish verifying it, we'll come back and redo it working on the right-hand side. Now, of course, when you're given an identity to verify, you don't have to do it twice. But I'm just going to do it that way in this case, just so you can see that it really didn't matter. You don't have to pick the correct side to work on. You can work on either side in a lot of these identities. So, working on the left-hand side, what can we do? Well, when you look at the left-hand side, you should notice that it's one big fraction. When you look at the right-hand side, there's two separate terms being subtracted. Now, in order to try to get to what the right-hand side looks like, think of it like this. You've got something like a minus b over c. You know, two terms being subtracted divided by something. And so one of the things from algebra that you can do is you can split that and make it a over c minus b over c. Now that's really just you're just taking it apart as if you were subtracting the fractions. Since there's a common denominator, you just subtract the numerators and use the common denominator. And so all we're doing is we're just undoing that process. So this is the algebra. Now how does that work out in the trig? Well, we'll have cosine squared in our first term in the numerator, and then that'll be divided by sine times cosine. So our c is the whole quantity, sine times cosine. And then the second term will be sine squared divided by the same denominator, sine times cosine. So now, in the first step, we have at least now separated the left-hand side into two different terms. And so the hope is that these two terms will simplify to what you see on the right-hand side. Well, it turns out they do simplify pretty easily here. We have a cosine squared in the numerator of the first term and a cosine in the denominator. So the cosine can divide out or cancel out. So that'll leave us just one factor of cosine in the numerator, and the cosine in the denominator will be divided out. So we have cosine in the numerator, and in the denominator there's still the factor of sine. So cosine over sine will be the result of simplifying or reducing the first fraction. Now if we come to the second fraction, we have a sine factor that will cancel out or divide out, and so we have sine in the numerator left because there was a sine squared there originally. And then in the denominator, the sine factor has divided out or canceled, and we have the cosine factor. That looks a lot better now. So it seems that we're making progress. Well, you have to keep your eye on the right-hand side. The right-hand side says we need to get to cotangent minus tangent. But if you remember your quotient identities from the previous page when we recapped them, the cosine divided by the sine is the cotangent, and the sine divided by the cosine is the tangent. And so we're done. And that verifies the identity. And at that point you could move on to the next exercise. But like I said a few minutes ago, I want to show you that you didn't have to be clever enough to choose the left-hand side. That's not the only way this could be done. We could have worked on the right-hand side. And so let's do this again. Do it again, working with the right-hand side. Okay. Now, so, working with the right-hand side, I have cotangent x minus a tangent of x. And remember, I'm trying to get to something. Look at the left-hand side. The left-hand side has got sines and cosines. So that kind of suggests, or that's a pretty strong suggestion, we better change these cotangents and tangents into sines and cosines. So again, we use the quotient identity, and we'll have cosine over sine replaces the cotangent, and then tangent is replaced by sine over cosine. Now, at that point, we're still looking at where we're trying to go, and on the left-hand side, there's just one big fraction. And here we have two separate fractions that are being subtracted. So, how do you get from two separate fractions being subtracted to one fraction? Well, you just have to subtract them. But in order to subtract them, you have to find common denominators. So in this case, the common denominator would be the sine times the cosine. So we have to multiply the first fraction, top and bottom, by cosine. And we have to multiply the second fraction, top and bottom, by sine. And the reason we have to do that is because we need to keep the common denominator of sine times cosine. And over here we had a cosine factor, so now we have a sine cosine in the denominator. And they have to be subtracted. But now once we have the common denominator, so this algebra here was getting a common denominator. Now, once we have the common denominator, we just have to subtract the numerators and write the common denominator. So when you subtract them, before subtracting, cosine times cosine can be simplified. That's just cosine squared. And then sine times sine is sine squared. So the numerator would be cosine squared minus sine squared, and the denominator would be sine times cosine. And so this would be subtracting the fractions. And so now that's the left-hand side, and we have verified the identity. Identity is verified. So, the point here was that you could work on the left-hand side, or you could work on the right-hand side. Now, in theory, that's always true. In practice, sometimes it's easier to work with one side than the other. If you go back and look at example 1 again, you'll see it was much easier to work with the left-hand side than it would have been to work with the right-hand side. So, that's example 2. Okay, example 3 is to verify the identity, or the claimed identity. The cotangent of x plus the tangent of x is equal to the secant of x times the cosecant of x. Well, now that's kind of a strange looking identity. It's saying the sum of two things is equal to the product of two different things. But, okay, so let's see if we can do something with this. Well, we have a sum on the left-hand side, and we know we can turn the tangent and cotangent into sines and cosines, and sines and cosines, when you take reciprocals, give you secants and cosecants. So it seems hopeful that maybe if we work with the left-hand side, we've got some things we can do. And there didn't seem to be a lot you can do with the right-hand side, but you might want to look at that. But I'll start with the left-hand side, and the first thing I'll do is change the cotangent to cosine over sine. So cotangent of x is cosine of x over sine of x, and then the tangent will be sine of x over cosine of x. Now again, we want to get a common denominator. And when you get the common denominator, the common denominator will be sine times cosine. So the top and bottom of the first one has to be multiplied by cosine. And the top and bottom of the second one has to be multiplied by, well, I'm sorry, the top and bottom of the first one multiplied by cosine. Top and bottom of the second one has to be multiplied by sine. And so we have the common denominator of sine, cosine, and we've got that in both terms now because we've multiplied top and bottom to make it happen. And so that's the common denominator part. And so now we just add the fractions. And we can also simplify. Cosine times cosine is cosine squared. So in the numerator we have cosine squared plus, in the other numerator we have sine squared, and that's all over the common denominator, sine of x times cosine of x. So now we have combined our fractions, and we've got one term on the left-hand side now, although it seems pretty messy. But hopefully you won't go too far in this topic of proving identities without having something send up a little red flag, or not a red flag, actually maybe a blue light special here. The bells are ringing. You got cosine squared plus sine squared. Anytime you see the cosine squared of x plus the sine squared of x, the Pythagorean identity says that that is just exactly equal to 1. So Pythagorean identity says that's 1 divided by the sine of x and the cosine of x. Now that was a big simplification. The Pythagorean identity. Gotta love it. Now, okay, so where are we in terms of trying to verify this identity? Well, if you look at the right-hand side, which is where we're trying to go, it looks like it's the multiplication of a secant and a cosecant. And a secant is 1 over a cosine, and a cosecant is 1 over a sine. Well, look what we have. We have exactly that. I can write this fraction as 1 over sine multiplied by 1 over cosine, because when you multiply fractions, you multiply the top, you multiply the bottom. So 1 times 1 is 1, and then sine times cosine is sine cosine. So we can separate our fractions then and see it's a multiplication, a product of 1 over sine, 1 over cosine, and that's just the cosecant times the secant. And since multiplication, a times b is the same as b times a, then that's what we wanted to get. We just have it in a different order, but it's exactly the same. So at that point, this identity has been verified. Now, you might want to think about, could you go back and work with the right-hand side and do this? I'll leave that to you to think about some. It's not quite as straightforward that way, but it can be done, of course. So, example 4. Now, example 4 is we want to try to verify that the quantity cosine of x plus sine of x all squared minus 1 divided by the sine of x is equal to 2 times the cosine of x. Now, that is quite a bit different on the left and right. On the left side you have a complicated looking expression. On the right side you've got about as simple as an expression can get, 2 times the cosine of x. So it's pretty clear you need to work with the left hand side because there's not much you can do with the right hand side. So let's see, when you see this left hand side, you think about what could I do to try to work with this, simplify it eventually. Well, one thing is that you've got a quantity being squared, cosine of x plus sine of x being squared. And so you can go ahead and use the distributive rule, or you may have called it FOIL, or you may have even memorized something for squaring. But the cosine of x plus the sine of x, quantity squared. I'm just going to do this on a separate line so you can see it's fairly lengthy and I want you to see the details. That's cosine of x plus sine of x times cosine of x plus sine of x, and that will be, when you use the distributive rule, we'll have cosine times cosine, which is cosine squared of x, and then we'll have sine times cosine, sine times cosine, and that's everything multiplied by cosine, and then we'll have cosine times sine, and I'm writing sine times cosine, and then there's one thing left, and that's sine times sine, and that would be sine squared. So I have to go down to the next line there. So I've got 4 terms, and the first one is cosine squared, and the next 2 are actually the same, sine times cosine. So I can simplify that to cosine squared plus 2 sine of x cosine of x plus sine squared of x. Now, that's the squaring part. We've squared. Now, we still have to go back and put all of this back in place of that square. But one thing we'll do before we do that is to notice that we've got a cosine squared plus a sine squared. And it's an addition, so we can rearrange the order of the terms. We can put the cosine squared and sine squared together, add those two together first. But cosine squared plus sine squared, that combination just equals to 1. So we just have 1 plus, and then what we had in the other term was 2 times the sine of x times the cosine of x. So the quantity cosine x plus sine of x squared turned out to be equal to 1 plus 2 sine of x cosine of x. Now we'll return to the identity and we'll replace that entire expression that was being squared. We'll replace that by what we found out it was, 1 plus 2 sine of x cosine of x. But notice the last thing we have to do in the numerator is subtract 1. And then we'll have to divide by the sine of x. Well, as it turns out, it was good fortune, or perhaps planning on the part of the person who made up this problem, that we have 1 minus 1, and that gives us 0. So 1 minus 1 equals 0. And so in the numerator, we just have 2 sine of x cosine of x. And then in the denominator, we have sine of x. Now, notice there's a factor of sine of x common to the top and bottom, so we can divide it out or cancel, and that would give us just 2 cosine of x, and that's the right hand side. And so this one has been verified. Okay, so that's the end of example 4 and the end of this unit. Hope this is helpful.